Let's continue with our notes on compound events. So number 2, a card is drawn from a standard deck of 52 cards. What's the probability that it is a 4 or a 5? Once again, remember we have 4 different suits, and under each suit there are 13 cards. 3 face cards, the king, the queen, the jack, and then the numbers 10 down to 2, and then we've got the ace. So the probability it's a 4 or 5. Well, probability it's a 4. How many 4s do we have? There's 1 of each suit, so there's 4 out of the 52 cards. Or a probability that's a 5. Well, there are also 4 5s. This is an OR problem, so we add, giving us 8 out of 52. That reduces down to 2/13. It's a 2 out of 13 chance we reach in and pick either a 4 or a 5. What's the probability it's not a 4 or 5? Well, that's a complement. Remember how we talked about complements last lesson? It's neither a 4 or a 5. So if I have a 2 in 13 chance that it is a 4 or 5, the probability that it's not a 4 or not a 5 would be the complement, 1 minus 2/13, which would mean 11 out of 13 of the times it is not a 4 or a 5. On C, find the probability that it's a 4 or it's red. Once again, this is an OR problem, so we know we're going to be adding. Okay, the probability it's a 4. Well, we already talked about that. That's 4 out of 52 times we have a 4. The probability that it's red, well, there's 2 red suits. There are diamonds and there are hearts, and there's 13 cards of each, so 26 out of 52 times we have a red card. Now, these events are non-mutually exclusive. And remember what that means. That means there's an overlap. So we have some cards that are both 4s and they're red. We've got the 4 of hearts and we've got the 4 of diamonds. So we counted both of these cards when we counted 4s and when we counted red cards. So let's not count them twice. Let's subtract that off. So I have 30 minus 2. I have 28 out of the 52 times. I'm either going to pick a 4 or a red card. That reduces to 7 over 13. Okay, this next problem is a little different because we're talking about 2 die being rolled and looking at what the sums could possibly be. So we're going to make a chart, and I suggest you make this chart somewhere on your notes paper because we're going to refer back to it, and you might have some homework problems that deal with this. So we're going to make a sum table. When you roll 2 die, the smallest they can add up to is 2. If you roll 2 1s, they add up to 2. And the biggest they can add up to is 12. If you roll 2 6s, they add up to 12. So let's look at all the possibilities. So there's one possibility for rolling a 2. You roll a 1 on both die. And there's one possibility for rolling 12. You roll a 6 on the first and a 6 on the second die. But rolling a 3, we actually have 2 possibilities. You could roll a 1 on the first die and a 2 on the second, or a 2 on the first and a 1 on the second. The same thing goes for if we roll an 11. The only combination that'll give us an 11 if we roll a 5 and a 6. But I could roll a 5, then a 6, or a 6, then a 5. So in other words, it's twice as likely to roll, I'm twice as likely to roll a sum of 11 than I am to roll a sum of 6. because there's a sum of 12. There's only one way to get a sum of 12. Well, there's two ways to get a sum of 11. Okay, rolling a 4. Well, I could roll a 1 and then a 3 and then a 1, or a 2 and then a 2. I'm just going to go and continue my chart. 5, do you notice a pattern here? I have one way to roll a 2, 2 ways to roll a 3 ways to roll a 4. So how many ways to roll a 5? Well, probably 4 ways. A 1 and a 4 and a 1. A 2 and a 3 and a 2. Let's go back to the other side of the chart. 10, it looks like there should be 3 ways if we're going to keep up with the symmetry of this chart. I could roll a 4 and then a 6 and then a 4, or I could roll both 5s. So for 9, it looks like there's going to be 4 ways. A 3 and a 6 and a 3, a 4 and a 5 and a 4. So it looks like for 6 and 8, summing to 6 and 8, I'm going to have 5 ways, and 7 looks like I should end up with 6 ways to keep this pattern going. So let's continue on. 6 is a 1 and a 5, or a 5 and a 1, a 2 and a 4 and a 2, or I could roll 2 3s. An 8, a 2 and a 6, or a 6 and a 2, a 3 and a 5 and a 3, or I could roll 2 4s. And lucky number 7, it's lucky because it's the most likely to happen, because there are 6 possible ways. A 1 and a 6 and a 1, a 2 and a 5 and a 2, or a 3 and a 4 and a 3. Now let's see how many possible combinations we have here. There's 1 here, 2, 3, 4, 5, 6, 5, 4, 3, 2, 1. If I add all those up, there are 36 possibilities that can happen. So let's use that to answer some questions. We'll keep coming back to this chart. So what's the probability the sum is a 7 or an 11? Well, the probability that I roll a 7 is 6 out of the 36 times. The probability that I roll an 11, well, that's 2 out of the 36 times. Now this is an OR problem, and in ORs we add. So 8 out of the 36 times, or 2/9 if I reduce it down, 2 out of 9 times, I'm either going to roll a 7 or an 11. What's the probability that it is at least a 10? Well, at least a 10 means it's a 10, anywhere from a 10 to a 12 for the sum. Let's see here. There's 3 possibilities here. 2 for the 11, 1 for the 12, so there's 6 total possibilities. 6 out of the 36 times, or 1 out of 6, I'm going to roll at least a 10. Okay, the probability that the sum is less than 10. Well, less than 10 would be everything left over. So that would be 30 out of those 36 times, or 5 6, the complement, that the probability that it's at least a 10. Okay, at Study More University, 46% of the students are female, 13% of the females are psychology majors, 9% of all students are psychology majors, and a student is picked at random. Find the probability that is a female psychology major. Now, this is like saying they're female and they're a psychology major. So that and implies that we're going to be multiplying. So the probability someone is a female at the university is 46%. The probability that they are a psych major is 13%, giving us a total of 6% of the students are female psychology majors. The second problem is an or. So ors, remember, mean we're going to be adding instead of multiplying. So what's the probability the student is a female? Well, that's 46%. The probability that they are a psych major, well, what percentage of the student body is a psych major? Well, 9% of all students are psych majors, so 0.09. Remember, that's not 0.9, that's 0.09. But here's the problem. There are some students that fit both these categories. We counted them twice. We counted them because they're female, and we counted them because they're psych majors, so we want to subtract off that overlap. And the overlap is the 13% that are both females and psych majors. Put that together, and we get 49% of the population at Study More are either female or psych majors. Let's go ahead and let's switch to 6 because we're running out of time. An urn contains 8 balls identical in every respect except color. There are 4 green, 3 red, and 1 white. Okay, what's the probability that it's green or white? Well, the probability that it's green, well, there are 4 green out of a total of 8. So 4 out of 8 times we pick a green ball. Okay, the probability that it's white, well, there's only 1 white one. So 1 out of 8 times it's white. This is an or problem. Or means we add. So 5/8 of the time it's either green or white. Okay, this time we're not replacing it. We want the probability that it is first red and then the second one is white. We're picking 2. This is an and problem. So the probability we reach in and pick a red one first, well, there's 3 red ones out of 8. The probability we reach in and pick a white one is 1 out of, well, it says without replacing. So how many balls are left in this urn? Well, there's only 7. So 1 out of 7 times now we're going to pick the second ball is going to be white. Now this is an and problem. And implies we're multiplying. So 3/56 of the time that is going to happen. And finally, if you draw 2 balls without replacing the first one, what's the probability that one is red and the other is white? Now the difference here is that the order doesn't matter. We could first pick a red ball and then a white ball, or we could first pick a white ball and then a red ball. So if you look at number 6B here, this is if we first picked a red and then a white. What about if we first picked a white and then a red? Well, let's see. 1 out of 8 are white, and 3 out of the remaining 7 are red. Okay, that probability is the same as this. So the probability of either red then white or white then red, the order not mattering, is going to be 3/56 times 2. We're going to double the probability that that can happen.